Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on March 2nd, 2026, just yesterday. It introduces RubricBench, a benchmark containing over 1,100 pairwise comparisons, which uncovers a severe 27% accuracy gap between human annotated rubrics and those generated by state-of-the-art models. The paper is titled RubricBench, Aligning Model-Generated Rubrics with Human Standards. And as we'll see later, the results indicate that this inability to define valid criteria is a fundamental bottleneck that scaling compute alone might not solve. And for those interested in the implementation, the authors have shared their code on GitHub. Table 1 compares the current landscape of reward model benchmarks to show exactly where the gaps lie. In the top rows, general-purpose datasets like RewardBench 2 and Help Steer 3 offer diverse domains, but they lack the rubric-based infrastructure and human annotations needed for deep evaluation. Conversely, the middle rows show that specialized benchmarks like PaperBench incorporate rubrics, but are limited to single domains. RubricBench in the final row is the only one to check every box, combining diverse domains with high discriminative ability and human-authored rubrics. Well, Figure 1 details the construction pipeline designed to fill those gaps. It starts on the left with diverse source pools. Then, Stage 1 filters for hard samples, specifically targeting cases where a response is polished but factually wrong, like this example showing a 2 weeks notice when 10 days was requested. Next, Stage 2 involves human annotation, where experts write rubrics based only on the instruction to ensure objectivity. This rigorous process leads to the final benchmark of over 1,100 samples shown on the right. So having seen the pipeline, Figure 2 breaks down the statistics of the resulting benchmark. On the left, the sunburst chart displays the domain composition, where general chat and coding make up the largest portions, followed closely by STEM and instruction following. Moving to the top right, the length distribution reveals an interesting pattern. The green curve shows that rubrics are much shorter than the model responses in orange, meaning they focus on concise, essential constraints. Finally, the bar chart below indicates that most domains average about 6 checklist items per prompt, though safety is slightly lower because those violations are usually more direct. Alright, with the benchmark defined, Table 2 presents the main results, and the performance gap is striking. First, looking at the baselines in the top section, standard reward models like ARMO-RM and Tulu-3 hover around 47 to 50% accuracy, essentially coin flipping on these hard samples. In the middle section, self-generated rubric methods, where the model writes its own criteria, fare only slightly better, reaching the high 50s. But the bottom section tells the real story. When we provide human-annotated rubrics in the Oracle setting, accuracy skyrockets to 85%. This proves the models can judge correctly, but only if humans first define what matters. Okay, Table 3 breaks this down by a specific model, isolating what the authors call the rubric gap. The columns track performance across 3 setups: vanilla scoring, self-generated rubrics, and human-annotated rubrics. Look at DeepSeek version 3.2 in the first row. It starts at roughly 39% accuracy and improves to 58% when defining its own criteria. But when given human-written rules, it jumps to 85%. The final column highlights that this 27-point gain is consistent across every model, proving the bottleneck isn't the reasoning capability itself, but the ability to define the evaluation standard. So, Table 4 investigates exactly why generated rubrics fail by grading them against human standards. It reports rubric recall, which tracks how many human rules were found, and hallucination rate, which measures irrelevant additions. The results are telling. In the hallucination rate column, methods like auto-rubric and open-rubric exceed 70%, meaning most of their output is noise. Even CheckEval, which achieves the highest recall at roughly 54%, still includes significant irrelevant information. The authors describe this as attention displacement. Models produce long lists, seen in the average rubrics column, but fail to identify the specific constraints that actually matter to human experts. Wrapping up, 2 key takeaways stand out. Models possess the reasoning capacity to judge correctly, but they struggle to autonomously define the standards, creating a persistent rubric gap. This suggests that future alignment must focus on teaching models how to formulate values, rather than just scaling preference learning. That's it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.